Point, and we are the phone finders. My name is Aaliyah McAllister, and I helped complete the 3D modeling, the building and testing of the prototype, and the cost analysis, and I plan on attending UC Santa Barbara for computer science. I had two other members help me, and the first one was Jesse Aguayo, and he helped complete the 3D modeling and building and testing the prototype, and he plans on attending Cal Poly Pomona for industrial engineering. Then I had Kayleen Garnica, and she helped complete the interviews for feedback and testing the prototype, and she plans on attending Cal Poly Humboldt for an environmental education and interpretation major. So for our problem statement, we found that a study conducted in 2012 reported that 70 million phones are lost per year, and only 7% of the phones lost are recovered by their owners. And through further research, we were able to find that people are losing their phones daily, and it's harder to find your phones when they are dead or powered off because you cannot get any sound coming back from your phone, and you can't find it with GPS tracking while it's lost this way. So we ended up sending out a survey to the Mission Oak High School students, and they reported that they lost their phone at least once a month with 26.2% to daily with 22.6%. And currently, they would try calling it, pinging it, or using GPS tracking apps to find their phone whenever it's lost. And this told us that people are most often using forms of sound or GPS tracking to find their phones. And the top most common places that they would leave it were within their house, their car, and at school. And this told us they lost it near them in common places, and it would be within their close vicinity. And so for our site observation visit, we decided to go to the Mission Oak admin office, as they would be a good possible stakeholder for our product since students are losing their phone every day. And we first found a large wooden lost and found box that included many larger things that are lost, such as clothes, bags, and shoes. And through further questioning to the admin, we found that the lost electronics were kept in a drawer in the front office. And this was a locked drawer that we found many phones, AirPods with and without cases, and chargers in this drawer. And the admin would also say that students are losing their phone every day. Then we decided to do an expert interview with an anonymous AT&T representative, and they would state that phones are very difficult to find, especially if they're powered off or completely dead, since you can't get a ping back from the device. And they stated that 1 out of 20 times they're contacted for customer service, people are reaching out to find their lost phones. And since phones nowadays are very expensive, if it's lost, it's a very big problem. And they suggested creating something similar to AirTags that could function even if the phone was off. And so we went with these 5 design requirements. So our first one was tracking or pinging it without needing the phone's power. And so it couldn't use software tracking. And we wanted to keep a low cost, so we wanted to keep it under around $50. And we wanted to keep a small size and keep it under the size of smartphones so that it wouldn't get in the way. And we wanted it to be compatible with all major smartphones so that everyone can use it. And then we wanted it to be durable against dropping your phone so that in case you do drop it, it would stay intact. So for our present solutions today, we found the Apple AirTag, of course, and we found that it was lightweight, wireless, and compact. However, it was only compatible with Apple products. And we also found this wire attachment that you could connect to, say, your belt loop or your purse or anything. And we found that it had a sleek design, and it was external from your phone, and it was easily detachable. However, it could get in the way of your everyday activities. So here were our potential solutions, and the one here on the far left was a card that you could put in your wallet that had a button on it that would connect with a speaker that you would put on your phone, and it would ping the speaker. And then we also had a watch that had a button on it that you would push, and it would connect with an attachment on your phone, on the back of your phone case, that would also make sound. And then we also had a phone case that already had an attachment in it. And so for our decision matrix, we connected each of our solutions and designs to our design requirements, and we found that our watch concept was the closest to what we wanted to do. And so here was our chosen solution with a drawing of our 3D model. And so here we can see all of the dimensions for that. And so as we were building our prototype, we decided to change our design idea around halfway through because we realized many people don't want to wear two different watches. And so we decided to go with a keychain that could be attached to, say, your keys or your backpacks or your purses. It just allows for more versatile use. And in building it, we had to sand a lot from the printed pieces and drill holes into the attachment right here to allow for the sound to be released. So for testing our prototype, we decided that our major 3 tests to do would be distance, height, and if it can be heard by all. So it can be heard around 35 plus feet away, and it will stay intact if dropped up to 5 feet high. It can be heard by elders and it can be heard by those hard of hearing. And our prototype had passed all the tests above. And with our stakeholder feedback, we decided to go back to the admin office, and they approved it as a solution to the problem, and they suggested having it alert you when it was dropped so that you knew that you had dropped your device or left it behind. And then they also suggested to make it easier to change the batteries. And so here was our final prototype with the attachment here and the keychain here. With the button being pressed, it would ping our attachment. And so, yeah, it wouldn't need the phone's power since it's an outside attachment. And the cost, keeping it under $50, will be addressed in the next slide. And then the small size, the attachment is smaller than the phone itself, and it's compatible with all major smartphones since you can attach it to any phone that you have. And as we saw from our testing, it would be durable against dropping your phone. And then with our cost analysis here, we had our prices as a whole and how much we actually used from the whole. And our total cost for what we actually used was $17.16. And then we took the time it took to actually do every step and multiplied that by the minimum wage. And that gave us $37.07. And so our total for one unit was around $54.23. So we saw that we went a little bit over what we wanted, but it is very close. And then we wanted to say thank you to Andrew Duffick, who is the head of the engineering department, and the Mission Oak High School students and administrators for their help. Thank you.